Hi guys, my name is Jesse Precious and I'm a physics and math teacher and also a further math teacher, and I'm on a challenge to solve past questions, external examination past questions, and I want to follow them chronologically, or you say consecutively. So I wanted to start with the earliest years of WAEC, that's the examination. So we're going to do the objective section from 1 to 3 and then see where this takes us to. All right, so we have which of the units of the following physical quantities are derived? So we know that derived quantities are quantities that depend on other quantities for their measurement and definition. So that being said, let's tackle this from the area of dimension. We all know that given for area is more like in its dimension is given by L square, in other words, length times length. And we all know that length is the distance between 2 points, and that exactly is a fundamental quantity. So area depends on fundamental quantity for its measurement and definition. So we also have thrust. So I would like to put it to you that thrust is a kind of force, and if you attended secondary school, you must have been taught a kind of force which we call the upthrust. So which the formula is given by density times volume times um, acceleration due to gravity. So that being said, uh, I think you already know that this is the formula for upthrust. And we also have other formulas where we say velocity times mass flow rate. All right, that's more like an advanced section of it. But then in simplification, that would be change in mass over change in time, of which all of these things boils down to mass times acceleration, or mass times acceleration due to gravity. So, um, all right, sorry, mass times acceleration due to gravity. All right, so let me write down that here. All right. So we have thrust also to be a derived quantity. And then for pressure, the formula for pressure is undoubtedly known. So we have force over area, and all of this are kind of derived, but mass is a fundamental quantity. So we only have area, thrust, and pressure. So in the objective section, we have B to be our answer. All right, so the next one we want to talk about is the slope. Number two, the slope of a straight line displacement time graph indicates the dash. All right, we all know that slope, which I'm going to be calling m, is given by the change in the vertical axis, that's change in the y section, all over change in the x section. So provided we have a graph, all right, a linear graph of x being the displacement and t being time, so that means change in x over change in time, which we basically would define as velocity. And then to know whether it is instantaneous or uniform, I think that pretty much explains the straight line that was said in the question. All right, so what does it mean to be a uniform velocity? That means there's an equal change in distance with an equal change in interval or time, so to say. So that would be B as our answer. All right. So the next one we have is a man. A man it will exert. Okay, that's a wrong spelling, but I think I'd pardon that. We all can. So a man will exert the greatest pressure on a bench when he lies flat on his back, lies flat on his belly, stand on both feet, stand on one foot only, stands on toes of one foot. All right. I think the changes I'm seeing in the options has something to do with area, and the relationship between pressure and area are inverse proportion, something like this. In other words, when there's an increase in pressure, there's a decrease in area. And here we want to look at, if you don't understand this, just look at it from this angle, where pressure is equal to force over area. You'd agree with me that pressure will have its highest value provided area is at its least or minimum value. So in the objective, I think one with the least surface area exerting the pressure is E, because that would be standing on toes of 1 foot. All right, guys, I'll be seeing you definitely in the next section of this particular challenge. And I hope that you enjoyed this. Have a wonderful time. Bye.